Alright, going to talk about wavelength and amplitude, and the first thing I want to point out is that the amplitude and the wavelength are independent of one another. In other words, if I change the amplitude, the wavelength will stay the same, and if I change the wavelength, the amplitude will stay the same. So, let me adjust this. So, first off, the amplitude is represented by these yellow arrows here. Okay, the wavelength represented by these red arrows, and they picked kind of a strange place to measure the wave. Usually a much easier place would be at the two crests or the two troughs at the bottom here, but you know, they just picked kind of a random point. Alright, so amplitude, if I adjust the amplitude, you're going to see the arrow kind of change, but it's not going to get wider and it's not going to get shorter. So I change the amplitude. Okay, and again, amplitude determines the volume of the sound, and whether it's loud. This is going to be a loud sound right here, and this would be a much softer sound. And if you notice, the arrow, even though it might look like it's stretching because it's thinner, that's just an optical illusion. The length of that arrow is actually the same. So if you want to freeze your screen, measure it, and then come back here and measure it, I assure you that those measurements are going to be the same. The arrow, the red arrow, does not change. Okay, and vice versa. If I change the wavelength, let's see if I flatten it out a little bit and stretch out that wavelength. That's going to be that the wavelength is going to determine the pitch of the sound. So this would be a lower, deeper sound. And if I squeeze these waves a little bit tighter, then the frequency is going to be faster, which means there's going to be more waves per second. But you can see that the amplitude has not risen and the amplitude has not dropped. It stayed at that same level. So no matter how I move the wave, the amplitude isn't growing. Okay, the volume isn't changing. I'm just changing the pitch of the sound. All right, so I'm going to go to a different one, and this will illustrate that. So let me adjust the volume here. So when I hit a note, okay, you see that note, and you see the height of the wave, that its amplitude. So now if I really bring that down, that note is going to be at a much softer volume. Okay, and I can increase the amplitude with increase in volume, and that was really loud. We're going to try one more. All right, might want to turn down your speakers, and that's even louder. All right, so that's amplitude. Okay, and you can see that you know, that if I change the pitch, I hit different keys, the volume isn't moving. The amplitude is not changing, staying at the same level. Alright, now let's talk about wavelength. So here's middle C, and now if I go to the left side of the keyboard where the low notes are, you see how the wave is going to look different. And again, the height of the wave isn't changing, just the length of the wave. And then if I go to the right side of the keyboard where there's a very high pitch, you're going to see a lot of waves. Alright, so there's going to be a much higher frequency. And if you notice over here, you have a number representing the frequency of the sound, measured in hertz. And middle C should be what, 260? Yep, 261. Okay, so I changed the notes, and it sounds differently because the wave can either be stretched or it can be squeezed. If I change the volume, the height of the wave is going to be shallow or tall, and they're independent of one another. Okay, so I hope you understood, and thanks for watching.